As part of a university group assignment, my group and I were tasked with creating a smart mobility cane. This was because visual impairment can limit people's ability to perform everyday tasks, and can affect their quality of life and ability to interact with the surrounding world. The goal was to provide support to those people with visual impairment by designing and developing a smart cane that can communicate with the user. This video will go over the circuit design, 3D model, the code, and show a demonstration of how the created smart mobility cane works. As this was a group assignment, one of the very first things that our team did was split up the workload. As such, my part included designing the circuit as well as writing the code. One of the first things that I did was research current smart cane models and see what components were used. I learned that the most common input device used in these models were ultrasonic sensors, and the most common output device used in these models was a vibration motor. This was mainly due to the fact that these components were cheap and could form a very reliable interface where objects could be detected and that information could be discreetly passed on to the user. Our smart mobility cane utilized two ultrasonic sensors in order to detect chest and head height objects, as well as objects in front of the cane, as seen in the diagram. Chest and head height objects include things such as tree branches and overhanging signs, whereas objects in front of the cane include things such as people's belongings and chairs. Being able to detect people's belongings or a chair that a person is sitting on without actually hitting it with a cane can be beneficial, as it can avoid an awkward situation. So, with all that said, the final circuit diagram can be seen on screen. As shown, the circuit consisted of two ultrasonic sensors and one vibration motor to form the interface. The required voltage for this circuit was 5 volts, but through a step-up converter, only a 3.7 volt lithium-ion battery was required to power the entire circuit, as the step-up converter would boost the voltage up to the required 5 volts. Moreover, a rechargeable module was utilized to charge the battery via a USB port. This made the design easier to use, as having to change batteries can be quite a hassle and a more difficult thing to do than just plug it in a USB cable. Furthermore, the circuit was controlled by an Arduino Nano microcontroller. The small size of the Nano made it easier to design a relatively small 3D model that would fit all the necessary components. Finally, the circuit utilized two switches. One of these switches was a simple on and off switch for the entire circuit. This switch just simply turns the circuit on and off. The other switch, on the other hand, turns the ultrasonic sensor that detects objects in front of the cane on and off. This was because research and reviews from the visually impaired community on current smart canes revealed that a sensor detecting chest and head height objects is vital, as a standard white cane cannot detect objects at those heights. However, some users voiced that a sensor detecting objects in front of the cane was not needed, and interfered with how they would normally use a cane. Therefore, having a switch toggle on and off this bottom sensor catered to both types of these individuals. So, with the circuit now completed, I passed on this schematic to a team member who designed the 3D model of our smart cane. The team member designed the 3D model in 3D Experience, and the model was 3D printed via a Zortrax M200 Plus 3D printer. The model is made up of two parts, the bottom part and the top part. The team member took a very methodological approach and designed and 3D printed multiple bottom and top parts, and tried different layouts to see how all the components would fit. In the end, this 3D model was the final design. All the components were able to be fit inside, and in my opinion, it looks pretty great. So, now we'll move into the code. Here is the code used for our smart mobility cane. At the beginning, we initialize some variables that will be used to help us get and hold the distance of how far an object is from the ultrasonic sensors. Then here, we define what are the inputs and outputs of the circuits. Then this part of the code finds the distance of how far an object is from an ultrasonic sensor. And then this part of the code does it for the other ultrasonic sensor. Moving into our main loop, the ultrasonic sensor that detects chest and head height objects is labeled H, and the ultrasonic sensor that detects objects in front of the cane is labeled L. Now, the vibration motor can output 4 different vibration patterns, depending on which ultrasonic sensors detect an object. If both sensors detect something, then a fast pulse will be outputted via the vibration motor. If only the L sensor detects something, then a continuous buzz will be outputted via the vibration motor. If only the H sensor detects something, then a slow pulse will be outputted via the vibration motor. And if neither sensor detects something, then the vibration motor outputs nothing. So let's move into a live demonstration to show the 4 different vibration patterns. Alright, so this is a demonstration. As you can see, this is the prototype. We have 2 ultrasonic sensors. the one that detects chest and head height objects, or the H sensor, and the one that detects objects in front of the cane, or the L sensor. This switch over here toggles the L sensor on and off, just like that. And then this switch over here toggles the entire circuit on and off, just like that. So this is the power switch, and the switches are quite easy to turn on and off. The vibration motor is located over here, right over there. And then the USB charging port is located at the back over here. So then you just hold the cane like this with your index finger on the vibration motor. So then your index finger will receive the vibrations depending on which ultrasonic sensor detects an object. So I've implemented the circuit on the breadboard just so it's easier to trigger each ultrasonic sensor. So turning on the circuits and opening this serial monitor. So right now it shows neither. So let me just put my microphone closer to the microphone so it's you can actually hear the vibrations. So doing L only, we get a continuous buzz. Then doing H only, we get a slow pulse. And then doing both, we get a faster pulse. So H only, slow pulse. And then both, fast pulse. And then this is L only, and that's neither. And those are our 4 different vibration settings used in our prototype. So pretty nifty. And there we go. That's my Teams and I Smart Mobility cane that was created for university group assignments. It was a great experience. I applied my engineering skills that I learned throughout my subjects on a hands-on project, and I further developed my teamwork skills. The Smart Mobility cane works as intended and is able to detect chest and head height objects, as well as objects in front of the cane, and discreetly pass on this information to the user. So this brings an end to this video. I appreciate you watching. Thank you and goodbye.